Hello again, welcome back. For this video, we're going to talk about writing exponential functions. You can see what our goals are here. Construct exponential functions by using a graph, a description, or 2 points. Write equations and solve problems involving exponential growth and exponential decay. Okay, so here are some of our parts that we're going to talk about. We're going to construct those functions using 2 points. So we're going to substitute the values of x and y into the equation y equals a times b to the x. The result will be a system of equations in 2 variables, each with an a and a b as unknowns. You can then solve the system using substitution. We can do it given a graph. Use any 2 points to write an equation in the form of y equals a times b to the x as well. Substitute the values of x and y into the equation, and then resolve the resulting system for a and b using substitution once again. So we're using substitution for both cases. Then we're going to do it using a description. Use the information to create the table, then look for a pattern between input and output values. Keep an eye out for words such as exponential, linear, or multiple, constant, and factor, which can help you determine whether the function is exponential. Remember, if our function is exponential, we'll have a common ratio. So we're multiplying by the same amount to figure out our subsequent y values. For our first example, we want to write an exponential function given 2 points. Remember, we're substituting into the function y is equal to a times b to the x. So we're given an x and a y value twice. So we're going to substitute, let's say this first point right here, that's a y of 6 equals a b to the first power. Then we do the second one. That's going to be a y of 24 equals a b to the third power. So let's solve this first one for a. So a is going to equal 6 over b. Since there's a 1 right here on the exponent, it's very easy to do that. So now we're going to substitute that into the other equation. So 24 is going to equal 6 over b times b to the third power. This is b to the first. Then we simplify that, so 24 is going to end up equaling 6 times. Now we do b to the third divided by b to the first. We end up with b to the second. Then we divide by 6 on both sides, so b to the second ends up equaling 4. So we take the square root of both sides, and b ends up equaling 2. So it looks like our b value is a 2, so we end up with b equals 2. Now I still have to substitute to find the value of a. So let's go back to this equation over here. 6 equals a times b to the first. So 6 is going to equal a times 2 to the first power, which is just 2. Then we divide both sides by 2. We end up with a equaling 3. So a equals 3. So our equation appears to be y equals 3 times 2 to the x power. Okay, so the next one wants us to do this from a graph. Now, the y values were not selected for you. You have to go look at the graph over here and figure out what they are. Well, they've already given them to us. So I'm going to use the x and y down here and here since they're so easy. And we're going to substitute them into the same form. Y equals a b to the x. So the first one is, let me do a 0 power. So that would be 2.5 for x equals a times b to the 0. And the second one is going to be 1.25 equals a times b to the first power. Now, since this one on the left-hand side has a 0 power, b to the 0 power is 1, so 1 times a is a. So we end up with the y-intercept, which is the a value here, of 2.5. The reason for that is because of that 0 power. Now to figure out the b, all we got to do is substitute in place of this a 2.5. So 1.25 is equal to 2.5 to the b times b to the first. Divide both sides by 2.5, and b to the first, which is just b, is going to end up equaling 0.5. So we've got an a value of 2.5 and a b value of 0.5. So our final equation will be y equals 2.5 times 0.5 raised to the x power. Okay, for this next one, they want us to write an exponential function given a description. In a contest, a radio station is giving away $1,000 to the first listener who answers a question correctly. So in the table, you'll see after hour 0, they have 1,000. So that's our starting amount. So we already know that A is going to equal 1,000. If the question goes unanswered for 1 hour, the price increases by 10% until it's answered correctly. Write a function to describe this situation. Now that we have our starting amount, we want to find our b value, which is our common ratio. Remember, in a common ratio, we can just take a number divided by the previous one. So our output of 1331 divided by the previous, 1210 divided by the previous, and 1100 divided by the previous. And you can see we're coming up with 1.1 each time we do that. So our b value is 1.1. So our solution here would be y is equal to 1000 times 1.1 raised to the x power. For the next part of the video, we're going to talk about exponential growth, exponential decay. So solving exponential growth problems, we have a function here of y is equal to a times 1 plus r to the t. Y is the final amount, t is the time, and this is almost always in years, but we'll talk about that a little bit closer over here in interest. And a is the initial amount, or starting amount, so that's our y-intercept. And r is the rate of growth expressed as a decimal. So what that means is if we're talking about 30% growth, we got to write that as 0.3. And then we just add it to 1. And then we end up with a growth factor of 1.3. For compound interest is earning interest on top of interest. So it's not straight simple interest divided by time. So A is the current amount. R is the annual interest rate as a decimal, just like before. But the word annual here means it's based on 1 year. N is the number of times the interest is compounded each year. So N in this context means, let's say a bank's paying you interest every month. That's 12 times a year. You're being compounded. You're paying interest 12 times a year. That's what it means by compounded. So N is how many times a year. So if it's compounded once a year, N is just 1. If it's monthly, N is 12. T is time in years, as I said before. When we get to this point, T would be in years. And P is the principal amount, or the initial starting amount. So you notice that N is in 2 places here. It's on the inside and on the outside. So the R, since it's an annual rate, you got to adjust it for the year. And T is in years also. So if it's 12 times a year, you have to adjust that for 12 times during that entire year as well. Okay, so for our growth example here, the gross domestic product is the monetary value of all goods and services produced in a country in a specific time period. The GDP per capita is that value divided by the population. So one model says that the GDP per capita of the United States was $13,513 in 1946. That sounds like a starting amount. So my A value here is going to be 13,513. It's increased by 2% every year, so the rate is going to be 2%, but I want to write that as a decimal, so 0.02 is how I want to use it. And then they want us to write an equation to represent the GDP per capita after T years, where A represents the initial amount. Okay, so I already got that information. So that's going to be Y equals the initial amount of 13,513 times 1 plus the rate of 0.02 raised to the T power. So they said use T instead of X. Then I'll just simplify that a little bit. And I have 13,513 times 1.02, so that's bigger than 1, so it is a growth raised to the t, although it's not growing very much, it's growing by 2%. Then it says if this trend continues, calculate the GDP per capita in 2016. Remember, t is the number of years, and it's going to be number of years since 1946. So how many years are there from 1946 to 2016? It looks like a t value of 70 years, so y is going to equal 13,513 times 1.02 raised to the 70th power. And you will have to use a calculator here. So y ends up equaling, raise this to the second power, times 13,513. And we end up with approximately, it's not going to be exact, but approximately 54,046. Okay, so here we have a compound interest calculation. Don't forget the compound interest works like this. Y is equal to the initial amount here, times 1 plus, now the rate's going to be divided by n, which is the number of compounds, raised to the n, number of compounds again, times the amount of time. So the initial amount that she invested here was 5,000. So y is going to equal 5,500 actually. And then 1 plus, now the rate is supposed to be as a decimal, so 0.0325. And it says compounded quarterly. That means 4 times a year. So we're going to divide that by 4. And then 4 times whatever number exponent is. And they do ask us how much in the account after 5 years. So let's adjust this number here first. So y equals 5,500 5500 times 1 plus now 0.0325 divided by 4 comes out to 0.008125 raised to the 4th power. I'll just simplify it a little bit more. So 5500 times 1.008125 raised to the 4 times. Now I'm going to raise this to the 5th power times 20, which means over 20 years, 4 times a year, it'll come out to the 20th power. So we're going to take this number here and raise it to the 20th power. And then when we get our answer, we're going to times that by 5,500, and it comes out to about 6,466 and approximately 22 cents. So this is an approximation. And yes, you're going to need a calculator that can do an exponent to do this. Now we'll take a look at problems that involve exponential decay, and you'll notice the only difference here is we have a minus sign. Everything else is the same, only instead of the value getting bigger, the value will end up getting smaller. Okay, so our first example then, in banking, a dormant account is one that has not been used in over a year. Bank charges a monthly fee on dormant accounts of 0.8% on the account. One dormant account initially had 1,609, so we want us to write an equation to represent the balance after T months. So our initial amount is 1,609. Our rate is 0.8%, which means I have to write that as 0.008. Remember, it's got to be a decimal equivalent of a percent, so I'm going to use this as my R. Now, normally, the T is representing years, but they specifically told me it was months, so I don't have to adjust this by the in values. So I'm going to write the equation y equals the initial balance of 1,609 times 1 minus 0.008 raised to the T power. Y equals 1,609, and then 1 minus is going to get me 0.992 to the T, which represents 99.2% still remaining each month. That's how we interpret this factor there. Estimate the balance in the account after a year. Now they tell me that T is in months, but then give me a year. So a year would actually represent 12 months. So T is equal to 12. So Y is going to equal 1,609 times 0.992 to the 12th power. And you are going to need a calculator to do this. So raise that to the 12th power first. Then times it by 1,609, and Y equals approximately 1461. Remember, Y is the ending balance here.